So this is the second of the insider trading totalization talks, and I'm happy to be able to welcome a friend and former colleague, Nat Oppenheimer, here. And I also want to take this chance to thank Troy in helping set up these talks and bringing in these guests. So he's been doing a lot of the heavy lifting behind these events and the studio. And so it's important to say thank you to you, Troy. This wouldn't happen without you.
Nice help now.
Nat is a civil engineer. He's a principal at Silman Associates in New York, where he's worked for 22 years, despite the fact that he looks like about a 12-year-old boy. So I don't understand when, how old you were when you started working at Silman, but he's been there for a long time. He also teaches at Princeton. He's been teaching at Princeton since 2000 and has taught, and I don't know if you're still teaching at Columbia and Parsons as well.
Yes.
Are you?
I guess once in a while, but not.
So you're dedicated right now to one school. He's been a principal for working with architects ranging from Diller Scofidio to Stephen Hull, Renzo Piano. In other words, a range of projects that you know and personalities that you wonder how one can work with them. So that might come out a little bit in the questions and answers. He also, I think, indicative of Nat's ability to engage architecture in a way that I think is a very fruitful model for an engineer. Is one way that's indicative is his professional association. So you're on the board of the Salvadoria Association, but you're also on the board of the Architectural League. If I'm not mistaken, are you still the treasurer?
I was just made treasurer, and I was told the only reason was because I was an engineer.
Yeah, exactly. We trust the engineers with the numbers, but that his dedication to the Architectural League, which has been for a long time, I think, is indicative of his really having a very firm foot within the world of architecture. So, without further ado, the story of the structure and the structure of the story.
I'm supposed to turn
Nat.
Is that on? Yes.
You're on.
All right. Thank you for having me. It's great to be down here. We've done a couple of projects in Houston, but I hate to admit it, but I've never been to Rice, so it's a very nice campus, and we had some good conversation already, so I'm looking forward to more. I have about 20 minutes, I think, or 25 minutes just to sort of describe what I do and how I work. When I spoke to Sarah and Troy about coming down, I've been raised in this firm, Robert Silman Associates, that believes in very little self-promotion or firm promotion at all, so you may not know of us. And I've just been trained my whole life never to say anything about myself or the firm. So I sort of said to Sarah, what should I talk about? And she said, the way you work. And I said, no, all right, so we'll do some project stuff. She said, no, you work. And I said, oh, I've never done that before. So this is the first time I've done this sort of lecture, so bear with me. I want to start sort of at the beginning. This is a photo of my father, the one on the right, at Black Mountain College. He was a student at Black Mountain College. He was his mentor is Charles Olson, and he was there for 4 years in North Carolina. Those of you who don't know, it was a major art institute, never accredited, but most of the major movers and shakers of the art community came out of Black Mountain. And he was a working poet his whole life, which, for those of you who know anything about poetry and working, is a pretty laudable thing, that he made a living and supported his family for many years as a poet and a teacher. And one could easily say, as I think about my own profession and have this opportunity to talk about it, the simple version would simply be that I rebelled. I grew up in this household with a poet for a father and a writer for a mother, and a younger brother who went on to found a reggae website, a reggae label actually, EasyStar.com, for those of you who want to buy some reggae. And that I was just the one that decided to be Alice P. Keaton and get up at 4 in the morning and go design structures. But the more complex story is that my dad took half a year, I think a term, and then he dropped out at Cornell in the engineering school. And throughout his entire life as I was growing up, the way that he would relax, other than watching really bad TV, was to doodle house plans on 8 to an inch graph paper his whole life. And we have all these. He died about 20 years ago, but in his archive, there's just boxes of these graph paper that he would save. He'd never do elevations, he'd never do sections, he'd never do renderings. It was all about sort of a crossword puzzle of how you work out space. And that's how he relaxed. He'd sit in his easy chair every day and doodle houses. So there's that part of it. And I think that in the same way, as the title suggests, I've constantly been searching for stories in the jobs that we do, and I think that some of our success and what we try to do is find that narrative thread in projects, find something, because in the reality of building buildings, and I think one of the things we're most proud of as a firm is that we've gotten a lot of stuff built, a lot of stuff that people at the beginning say can't be built or won't be built or the client won't buy into it. And I think the important thing, and people often hear me, and people have been to a bunch of crits with me, probably get sick of it, I'm always looking for that story. And part of my criticism very often on projects is that the thread is lost. You know, you tell a story at the beginning, and then something's just a mess. You don't follow through with the plot line. And I think the success of building buildings often comes from finding a very simple and clear plot and some characters at the beginning, and carrying it all the way through to the end. And if you need to cut some characters and edit in the middle, you do that. But that you're able to tell a clear and simple story. The other part that made up my career, just as a digression, because it happened to work out well for this story, is this is a photo taken in Houston about 13 years ago. You could tell by the facial hair. I still look like I'm a 12-year-old boy. One of my closest friends who grew up in Houston in the middle, who was getting married on Halloween, and it was a costume party wedding. Me and my other best friend and his wife came down to Houston for the wedding and dressed up as chefs or cooks. We were never chefs, but the four of us had worked together at a number of New York City restaurants growing up. I had worked in restaurants from 12 years old, and I actually continued after the beginning of my career at Silman when I was about 22 for about 2 years, till I was earning enough at Silman to no longer cook on a mesquite grill. And the reason I bring that up is that there's a lot of, and I don't touch on it that much in the rest of the show, but I've often talked to people, and I've often told young engineers in the office, a lot of my mindset has to do with my years as a cook and the idea of getting an appetizer out and then the entree. If you get the appetizer out and it's good, you can keep them busy for a while. And so I've often talked, because people don't understand that engineers often do a lot of calculations and the architect doesn't see anything happening, and they wonder if you're working on their project. So it's very important, and it's just my mentality my whole life has been, you get the appetizer out, you tear the ticket, then you can work on the entree. And so a lot of what we do is creating a story and getting something out that an architect can sort of literally chew on for a while and get into the project while we're developing the actual work as we go forward. So again, how we work, that's a big part of it. And unfortunately, the only sad note is that Jerry, who was a very healthy person somehow, passed away in his sleep about 2 years ago. So he is at about 42 years old. So that was not it was a poignant picture to find. I had to dig through a bunch of stuff, but I knew there was a photo from my trip to Houston. So today I'm just going to give you a brief four short stories and a haiku, and I apologize ahead of time for the haiku. I had to do it. I have the reason I'm only here for days because I have a 9-month-old at home and a 6-year-old, and there's a bunch of really great children's books out these days with various haiku and so on, so it's on my mind. So story one is The Sculptor and the Obsessed Owner. Very short story. This is a house that Stephen Holt designed in Long Island that we were lucky enough to work on, the Tellius residence. The owner is a gentleman named Avi Tellius, pretty fascinating individual. He, I don't know if he had money to start with. He probably did. These stories usually start with a lot of money. It's not as fanciful as it often seems. But he got out of Harvard Business School, I think about 30 years ago or 25 years ago, maybe 30 years ago at this point. And the story goes that his father gave him, $20,000 to start a company. So he started a company that didn't make the widgets, but they repaired the widgets that go in machines. And he sold it about 5 years ago for literally $1 billion. It turned into his company. And he was very big, and he still is very big and committed to lean manufacturing. Toyota processes, all sorts of different names. It's very popular these days. But he did it excessively well. So he hired Stephen. He did like a little competition, and the competition was an odd one. I think it was Stephen Hull, Robert Stern, Richard Meyer. It was a bizarre sort of list of architects. And he picked Stephen's project, which was about a 16,000 square foot house on the site of the Jimmy Walker. Jimmy Walker was a famous mayor in New York City in the 40s, maybe. I can't remember. 30s or 40s? 20. Yeah, and that mansion was out in the middle of Long Island on an amazing piece of property. The mansion was no longer there. It burned to the ground in the late 70s in a Keith Richards freebasing accident when Keith Richards was borrowing the mansion for a couple of weeks.
are you talking about to these kids?
Yeah, sorry. That was sorry, there was a little fire that brought them into and so this project was going up right on that site. And the interesting story, and again, this project would not have gotten built this way unless there was an obsessive desire to do this in a way that no one else would have ever done it. It was a series that you can see, a sort of Stephen Hall series. It was built, it was sort of a successor to the Stretto House and this idea of a series of pavilions and all these different panels. And Stephen had this idea of each panel being this individual concrete panel. Now down in Texas, that's fine in terms of environment and so on. You could build panels and you insulate them in different ways, but it's not as critical as up in the Northeast. And so we went through a bunch of different designs, and most of them were aiming towards that you'd build a conventional building and clad it in some sort of precast. But neither the owner, nor us for that matter, nor Stephen wanted to do that. So at great expense and at great sort of going out on a big limb, the owner, who had just sold his company and had time on his hands, decided that he was going to build this in a tilt-up fashion. Now, Stephen had done this once before. We weren't involved, but he did the chapel in Seattle, where you take this very, very simple manufacturing process, and the idea where it becomes very efficient, and factories all over the South are built this way, is that you have your factory floor and you build this beautiful, gleaming concrete floor, and then you pour each wall right on that floor flat, and you just lift it up, and you pour the next one, you lift that up, and you lift the other two up, and you have a building. You put a light gauge metal roof on the top, and open web joists, and you're done. Nobody does this with Tiltup Construction, and this wasn't even Tiltup. But Avi fell in love with the idea of building all of these at once on the site and then lifting them into place like a jigsaw puzzle. So this took, in terms of research and getting to this point, probably took about a year and a half. They poured setting beds, so these were slabs they threw away. It sort of went away from the basic idea of Tiltup. They poured setting beds all around the perimeter of the site, and then carefully laid out. We spent about 9 months laying out every single unique panel, 108 panels, throughout the project, and then in one day poured every single panel with the same concrete mix, let it set for about 14 days. I think we let it go about 14 days. And Avi hired a PhD student from Stanford to do this sort of 4D understanding of how these were all going to be put together so you don't lock yourself out. And he basically erected them. He erected the entire house in, I think, 10 days. And it was all just welded together. There were embedded steel plates in each panel, put together, welded together, and it was done. And then we poured some floor slabs, and the house was then, because Avi, as wonderful as he is, as much as he likes lean construction, he hates the idea of paying a GC more than he should. So he basically tried to GC it himself, and it's still going on to this day. I think he's living in it, but it continues on 3 years later. With him doing some finishing touches to it. But the actual structure went up in about 10 days after a 9-month period of preparation. So again, the story here, these are all loose stories, but the story here, you know, that's something we always talk about because we get hired, oh, you did the Tellius residence, let's just go do a concrete house. You have to sort of understand the story from the beginning. It's not about efficiency, although it's an efficient idea. It's not about, you know, the best way to keep the thermal and moisture out because this is all on the outside and insulated on the inside, so your structure is sort of very exposed. It's not about conventionalism. It's about the idea that you're going to build a sculpture and you're going to do it in a way that's adaptive and you're going to have fun at it. And that, once you had that story, and that was what we all bought into, everything fell into place. If you had an owner that said, I want this to be as efficient as possible, you would have never gotten to this place. I mean, Avi believed this was as efficient as possible, but not in the conventional sense. So some of the details just close up. After it was built, you see the different joints that all fit together, and it went together quite nice at the end. I think there was just one panel that was off a little bit. The second story is a very, very fast story. This is Puma City that Low-Tech designed. We've done all these different container buildings with them. This was in terms of being constructed, and it was constructed over and over again, the most successful of those, although there's a lot on the boards. There's one that just went up in Korea that they did, APAP, that's, I think, about to get a lot of press. It literally just finished. Low-Tech, as many of you maybe know, have quite an obsession, and I say that in a very nice way, with these containers. Put a container anywhere you want. And so we've done a number of projects, most of them on the board still, but with the idea of every different way of manipulating containers. And it's a fun project because the basic idea of the container, and again the story, is that this is an incredibly efficient structure if the walls are there. Now the issue is for us structurally is that to connect three of them together and to make it a usable space, you have to put holes in the wall, which immediately take away all the structural efficiency of the container. So you end up reinforcing around these openings and creating a sort of shear wall with a hole in it. And there's a lot of modeling that goes into it. It's more complicated than it may seem. The key also is that it's all supported on the points, on the corners, and if it isn't, then you have to add a sort of post in there, because all of these containers are just corrugated tin. I mean, it's metal, but it's like a corrugated tin wall, and that's it. So if you put a lot of load in the middle, it's not designed to take that. You end up putting a post embedded in the corrugated to take that point load at the edge. But it does span nicely from support and then cantilevering out. So this was meant to be taken around the world. Puma City was built, and they didn't do it as much as they wanted to, partly because where they built it, everyone loved it so much and they had so much success that they left it. But it was meant to follow the Volvo Race around the world, the sailboat race, and Puma was sponsoring a boat. So the idea was that at every port they came into, and I think there were 8, they would ship this across as shipping containers on tanker, put it down in the port, sell Puma equipment, put it back on the tanker and get it to the next port ahead of the sailboat. They put it down in Alicante, Spain, and in Boston, right in front of the ICA, the Del Scofidio design, and then a number of other places. They're now, I think, looking to put it permanently in Boston, and one in New York as a permanent structure. So, again, very, very easy structure until you start manipulating it. So we have general models that we design. The stresses are on the corner. The blue is the lowest stress possible, spread out, very efficient. If you then take this and design Puma City, we had to make these meshes of every single container. What doesn't show as well here, and I'm sorry for that, but you know, you end up with openings and reinforcing around all the openings, so you get these stress concentrations where they weren't meant to be, and you reinforce that. Again, a little detour in the clear and easy story. If you wanted the perfect story of a container, then you'd have no openings and you'd walk in one end and out the other and live within there, but there's a limit to an 8-foot by 8-foot by 40-foot space, I think, in terms of functionality. This is it as the raw containers in the shop in China being put together. Again, very industrial, reused containers. Low-Tech's main idea is that you're reusing, that there's an environmental component to this. Simple connections, the channels at the base. This is the top container, so that's a rail, but every container has a channel top and bottom that all just get bolted together, can be reused. Very often using shipping container fixtures. Those are the 2 engineers from the office who designed Puma City. And Puma City fully open in Boston, filled with people on the cantilever. This was a fun project to do. One of the interesting anecdotes, when we had designed with Low-Tech and never got built, a large metal reclamation plant in Elizabeth, New Jersey, right off of Route 1, and it was going to be a 4-story office building. And it was all connected by shipping container connectors at each corner. And we had to go in front of the building department in Newark and explain how this worked, and they were worried about the shipping container connectors, that they were strong enough. When we pointed out that these containers are generally stacked about 8 stories tall and go on tankers through the worst seas in the world, and that any load they see, earthquake, wind, anything, pales in comparison to the load they see when they're out on the high seas, they sort of started to get the idea that this was not, this could be something that could be possible. And they actually passed it and gave it a building permit based on that. So I know I'm being taped, so I'll be very gentle. This is a project out of one of Troy's offices. To Columbus Circle with Allied Works with Brad Clopeville. I'm calling this a fairy tale, and Brad and I often discuss this. So if he sees this lecture, I hope he won't take offense. This was the restoration of the what was affectionately known as the Lollipop Building in Columbus Circle. Completed about 3 years ago. Allied Works won the competition. And the building was actually a very unique but simple structure. It's a phenomenal site in New York because you get all 4 exposures. I don't think there's probably, I can't even think of another site in New York City and Manhattan that you're on an island like this. So it was an incredible opportunity. And Brad's design, as I'm sure most of you know, many of you know, involved cutting this sort of snake through the facade. Now the structure itself, as unique a building as it is, was fairly straightforward. There's a very stocky and strong concrete core in the middle with elevators and stairs, And then the exterior wall was a bearing wall as well, and the slab spanned 20 feet from the core to the exterior wall. And the building had an odd shape, so there was different ways it spanned out. There was joists and so on, but it was all a concrete structure. So cutting this in the facade obviously had an impact on the structure of the exterior wall. Brad often, and he still goes on tour, telling the story that these are these incredible cantilevers and that we did this phenomenal job cutting this snake through there so that each one of these tongues sticks out and cantilevers over this major piece. The fact is that there's a 3-inch by 8-inch steel plate that is located basically at each of the, I don't know if I have a laser pointer, but at each of the edge of the cantilever going both directions, so that the beams, the wall is still doing something it wasn't intended to do, and it didn't have to be reinforced. We were able to justify it working as a beam instead of just a big wall. But there is a support. It's not a cantilever. There's a pin support that's buried in a window mullion at every floor. Now that pin support at the base, these are pretty heavy. It's a very heavy building. At the base, it's taking about 1.2 million pounds of load. The one story I'll tell you there. So if you hear Brad lecture on this about the phenomenal, he called me once, he said, you got to send me that stress diagram that shows all the stress at the cantilevered end. I said, I don't have a stress diagram that shows all the stress at the cantilevered end because there is no cantilevered end. And then he commissioned an article about the building, and they called me up and said, you got to send those images of the cantilevered end so that I could put it in the article. And I said, there is no cantilever. So this has gone on for about 5 years. One of the interesting things about the pin, as a side note, is that Sealy did a beautiful job, as always, on the curtain wall that surrounds this, on the terracotta curtain wall. And the curtain wall ran very close by the wall, and the wall was a built element, so it wasn't perfectly straight. And then one of our engineers came out to the site one day on the lower level, and the steel worker from Sealy was grinding the pin, the 3-inch by 8-inch pin that had 1.2 million pounds in it, because his mullion didn't fit. He was sitting there literally as a grinder trying to grind out about 3/4 of an inch of the pin. And we stopped him and we said, you probably want to grind the mullion and not the pin. And we got into about a half-day discussion of which was more important. We won out on that. So the story 4 is another job that Troy was involved in. And I swear it's very funny. I did not think of this as I was preparing these slides. But thank you, Troy, for inviting me down. This is your thanks. This is the Milstein Hall. This is the sort of just the combined monster here. The Milstein Hall at Cornell that OMA designed. These heroic trusses in there. I'd like to, it's a nice story to say that this was the idea from day one, and OMA was certainly on the idea of cantilevering from day one. But in all honesty, in schematic design, they were very, very set and happy with a row of columns on the other side of University Avenue. That's how the building was designed. It was all about a rigid grid with inside with no trusses, very straightforward design, and a nice row of columns right on University Avenue. Unbelievably, it was Cornell who said, we don't want any columns on University Avenue. I don't remember if it was because they thought it was too much of a tunnel or it was too close to the foundry.
Or the city, the historic preservation board in the city wouldn't get approval because that building on the left is one of the most historic buildings on Cornell campus.
Right, the foundry is, yeah.
It's like an old New York foundry, and we were going to have columns too close to that foundry. So to avoid the lawsuit with the city, they said get rid of the columns. And get rid of the columns.
We had actually, as a firm, done the restoration of the foundry, so we had some. We said it wouldn't be a problem, but they didn't believe us. So the school went to OMA, I guess, like right after, during schematic or right after schematic, and said you're going to have to cantilever this 48 feet out over on University Avenue, change the design, and you'll get extra money to do all this, in terms of construction budget. So we started to play with the idea of how you would do that. It's a very thin, relatively speaking, a very narrow floor-to-floor because it matches up with the floors in the existing building. Sibley's to the... Yeah, Sibley, which is where the architecture school is currently. So it's about 14 feet floor-to-floor. So we didn't have the opportunity to just grow this thing and say, okay, we have a nice deep truss. But there was definitely... we were fighting two battles. While Cornell said, look, we know we caused this issue, or the city caused it, and we're going to put more money in the budget, but we can't. It's not an open checkbook. And OMA said, well, I don't want to just have a bunch of old bridge trusses there that look like any old project. So we spent about a month. It was a fun exercise. I think it came out and bore nice fruit. And it's coming. Maybe. There it is. And what resulted, and I'll give you a sense of how we got there, But the story of this is that we decided to do this hybrid series of trusses. And we got into the study and the understanding, and we sent them probably about 30 different images of straight Varendale trusses, which is what OMA at first would have really loved to just have in front of them, just no diagonals. And then a whole series of your very traditional, here's what it would be most efficient. And we priced both, and we said there's some in between ground that the university will buy and that OMA will like. So the idea is that the heavier the loads, the more the stress in the truss, and the cantilever over to the right. There's also a cantilever to the left that zooms past Sibley on this part of the building. Those are all, just straight cantilevers. I'm sorry, straight simple spans. Wherever the load was greatest, the stress was greatest, over the fulcrum of the cantilever, is where you get the most diagonals to take that extra load. And wherever the load is the least, sort of out towards the end of the cantilever and back in the simple spans, you have the Varendale trusses. So it's sort of this idea of where you're asking it to do the least, you're using the Varendales which are less efficient but get the job done. Where you're asking it to do all the work, you're closest to a traditional, Pratt truss or any of the trusses. So there was probably 15 of these slides. This is just one to give you a sense. Here's your traditional truss, made OMA sick to their stomach to think that this is what would go through the architecture school. This wasn't the final configuration, by the way. There are 2 internal trusses as well that come through. So you're occupying this truss space in the architecture school. And then we sent similar 3D. This is just a 2D screenshot of the Varendale idea. You see these beam sizes. Those of you who've taken structures, 14 by 605. That's a 605 pounds per linear foot column section, fairly sizable. And 27 by 368, again, 368 pounds per foot. It's a lot of steel. It was probably about a $7 to $8 million option. The traditional truss was probably a $2 to $3 million option. I think they ended up spending about $4 million on the hybrid. So being erected, they went up about 3 months ago. It's fairly successful. I would say very successful. I'm always saying fairly to everything because I don't want to take too much. Right now, it seems very successful. This is out towards the foundry, and I'm sorry, no, that's Sibley. I'm on the other side. That's Sibley, so it's the more vertical Varendale trusses at the, again, lowest stressed areas. So the story with this, obviously, that journey between the 2 trusses and finding something that sort of satisfied everyone's interest. And finally, the bad and pathetic haiku. I didn't know I'd be videotaped, so apologies to my father. So this is a project none of you have ever heard of, but it's probably my favorite project I've ever worked on. There's a firm, Coco. Adam, oh God, now I'm going to forget their names. I can't believe it. We did this house about 8 years ago. 2-person firm, husband and wife. They came to me through friends. They were doing a little house. I think this house cost $250,000. It's in the woods in Pennsylvania. For a couple who were just looking for a very simple country house. I won't read my own haiku, you can read it, but basically they came with the idea that they wanted to do something modern, they wanted to do something fun, and this idea of a Seagram's building. And we've done a lot of this, but very often when you start worrying about thermal and everything else, you get in thermal bridging and everything in the Northeast, you often compromise and you end up with either an applied mullion or something going on. Because this was a small enough job and they wanted the platform at the base to cantilever out, we basically came up, and they had no money, so we came up with this idea that we would go to this shop in Brooklyn where we knew some people, and we'd fabricate these rings that were the exact same size structural beam, top, bottom, and sides. So it was a very simple fabrication. We fabricated, I think, 10 of them, and you'd basically erect this thing and hang the roof off the top, put the floor over the bottom because there was no basement, so you're just sitting on 2 footings and you could just build this box within it, and put up the curtain wall inside it, and this is all just exposed true structure, and it worked out exceptionally well, and is a great little house. I literally think, I'm not trying to tell a tall tale here, that it came in about I think $250,000 to $300,000 for the entire project, and was a very, very simple conventional house other than these rings we sort of brought over from Brooklyn and hung everything off of. So I don't know if that was the appropriate amount of time. Any questions?
I have a question about Milstein because I guess I'm surprised at I find the solution is ingenious, and I like how you walked us through it. I like how you walked us through all the projects. It was terrific. But one thing that surprises me is it becomes a sort of index of its structural load, which is very unusual for OMA to sort of make that something that it would offer any form of indexicality to or symbolism of, right? And did that ever come up in conversation, or was it seen as something that was so abstract the differentiation would override the reading of the structure?
No, the sense I got, and actually, Troy can share in this conversation, because I wasn't there in the office after we left. The sense they gave us was that there was very much an interest in reading this structural force, and in making a literal translation of what was happening, and not abstracting it too much. I think there were a couple of moments
not to take away Nat's framing of the elegance of the solution is it's really an awkward structural solution in the end, actually, because the programmatic demands of the whole idea of having a simply supported Miesian box was that you have a very, very open floor plate, and people could walk around everywhere. You could configure students however you wanted to. Once you started putting the trusses, if you look at the angles and where you need head clearance, there's very few places where people could actually walk through a cross-brace truss. So even the cross-bracing that ended up in the cross-brace section of that truss isn't pure. The actual cords don't meet at a single point. They leave enough space that you can walk between them. And so the matrix that OMA would show if we showed this version was a programmatic breakdown where it's the most open isn't just where the forces are the least, it's also where the most connectivity is required between the projects, because ultimately that box is designed to connect to other buildings. And so that's where all the stairs happen, that's where the auditorium starts, so you can walk into the auditorium. So the thing that our office liked about it was that there's a tension between some sort of slightly refined structural solution, but not completely refined, because it's pushing back against this programmatic demands of the plate. And so that's, I think...
Yeah, and I probably did overstate it. I think the idea was it's all relative, that there was this understanding that we go a little more diagonal, but there was never the buy-in to, okay, over the support we're going to go fully diagonal.
There was clearly a moment between an $8 million Barrendale solution and a $3 million typical bridge solution that somehow had to be negotiated, and this was the kind of negotiation between all of these factors, not just structural.
We were talking in the studio before the lecture today about it wasn't just tonnage either. There's a very nice curtain wall around the whole building, so there's also this discussion not just of will you feel the vibration at the edge, which we had to control, which is fine, but how stiff do you need to make it to make the mullions and everything as small as you want to make them? What's the criteria, and so on, because the whole game changed when the cantilever went in.
And Mark was here last week, and he talked a bit about the sauna when he needed 20 inches. We didn't have 20 inches. We had maybe 30 inches, but we still had a 30-inch limit. That's why his beams ended up being plate girders.
Right.
They had to build up out of 4-inch steel plates in order to make sections that you just can't get rolled, essentially. So he had those kind of limitations he was working with too. So it kind of was like chasing your tail at some level. The more steel you put on the end, the more it's going to deflect, which means your curtain wall is not going to work. So there's a whole lightning exercise. But it was our office approached it from the point of view of how do we make this connectivity in the program that we're interested in making.
Yeah. One of the interesting twists at the end too is that there's a stair tower on one side outside the building that sort of was a crutch almost. It almost hurt the project in some ways. Once we went to his cantilever, there was like this hard point. This building wanted to be this very nice sort of, as not many people think it was nice, but a nice just simple droop at the end that's uniform. And instead you sort of had this crutch over here that was also mitigating that it twisted more than it just came over. So,
It seems like one of the things that would differentiate us from 50 or 75 years ago is that there might be 3 models, I'm going to guess for the moment, 3 models of structure and the rest of the building relationship. So Milstein has structure that varies a bit, the way that you're describing it, the way Troy's describing it now. this building, for example, has structure which is completely aligned with the skin, and in a sense is an echo of 50 or 75 years ago. You could also imagine a building in which structure is normal and everything else is doing something else inside. I'm wondering if that affects the way that you work on a project. In other words, for one, how much of that comes from you, and the other, when somebody presents that prospects to you, how that affects your working model.
No, it entirely affects it, or at least in the projects that I think are the best projects. And it is something, it's something I've often said in crits too. I think it gets back to what I was saying in the beginning. It is searching in those first few meetings for what's underneath it all, sort of what's the story behind this. And to the architect, it's sort of putting them on the spot of saying, are you looking, we can be almost anything. Are you looking for us to be the sort of anchor to this building because you want to go do your thing? Are you looking for us to play with you? Or are you looking, and sort of sussing out which way this really wants to go? And I think the successful projects, the most successful ones are the ones that we sort of really come to a common understanding from day one, and you're not constantly fighting each other. Why are you? Because I think if you find that point, if you really get on the same page early on, and the architect says, I want you to be the one that says, I need a column here. This is important to me. Then you know your role. And there have been plenty of projects that aren't as productive or successful, where you're brought in early and it said, I need you to be that role, but really they don't want, why do you keep trying to put a column, or you're put in and it's not, why do you, it's all of it's important, and I've learned to embrace all of it, but there are projects where you sort of become a marriage counselor for the client, and structure is often that, between the client and the architect, you become the marriage counselor, and you get separate calls from each of them saying, look, I need you to just put some column grids in this building, and the architect saying, I don't want you to put any column grids in, and those aren't as successful. But I think the ironic part about that is that you can not put a grid in and play a game that goes way off the reservation with an architect and be more efficient than sticking a grid in if the client's willing to take that trip. That's the magic to it. You can, if you're willing to get to that place and the client's willing to let you go to that place, you can come back around to a place where the structure is incredibly elegant and gets them what they need, and the architect's happy, and it's, maybe not cheaper, but it's the right structure for it. And you've heard me, the other thing, in many crits, what I'll often say, and it sounds like an engineer just saying it, but there's something else in my mind, and I always have to preface it with the student because I don't want them just their eyes to glaze over. I'm always very interested in, and it sounds horrible, but the appropriate structure, in a good way. Like, what's the right structure here? And I think a lot of real projects, a lot of student projects, sometimes take a left turn when they look at the structure as their opportunity to be heroic, and maybe it doesn't have to be. There are projects where the best structure is a couple of 2x6s in a ring that holds up the roof, and that's all it is. And it doesn't need to be anything else. My father used to, one of his poetry classes, there's a photo of him sitting at a table, much like this, it's sort of eerie, with he wrote on the board behind him, Moby Dick is just a whale, because he would teach Moby Dick every term, and he would yell at his students that before it became Moby Dick, it was a book that people enjoyed reading about whaling, and that you shouldn't worry about it all. Read it once because it's a fun whaling story. So a 2x6 wall is there because it does a really good and simple job, and sometimes that's all you need. So it's I don't know if that answered the question, but it's sort of always that play at the beginning of what do you want? What do you need?
Well, it does seem that in each of those four stories, the architect has a fascination with a kind of conventional constructional or structural system, but that the architecture, the aesthetic of it comes from, I would say, the subversion, but at least the sort of playing it out in terms of all of the frictions that are possible. And that the result of that, as you mentioned in each of those cases, is that the cost is much more. So it's interesting that in the last example, the haiku, that the resonance between the kind of structural intention and the effect is very close together. But I assume you also work on buildings where the structure, the cost is an overwhelming constraint, right?
Absolutely. Yeah. No.
But do you have to go through this to reach a kind of architectural solution?
Yeah, I think and it's one of those classic things of sort of showing a slideshow of these, fascinating high-budget projects, except for the last one. And a large part of the work we do in our firm actually is low-income housing and university work with tight budgets and so on, not just Milstein Hall. And to me, some of the best work comes out of that. And I'm not just saying that. I mean, a lot of times that constraint can boil stuff down to that appropriateness in a way that having total, freedom doesn't. And it's nice. I mean, you can. And I'll give. What's interesting is people will also surprise you in cases like that. We did Higgins Hall with Stephen Hull, which is the architecture school at Pratt University in Brooklyn, and it was a connector building that had burned down, and he built it back. And Stephen had this idea that would be all precast concrete in every way, precast beams, columns. It was right after he'd done the MIT projects, Simmons. And so he was into this idea of precast concrete. Simmons was much more, monolithic and sort of fantastical. And this was meant to be much more down and dirty. And we got about through DD, and then we got with all these precasters, and they said, well, the budget from Pratt is not going to support sort of the wet pour that they did in MIT, meaning the sort of Japanese joinery, mortise and tenon, where you bring the concrete together and you pour some concrete and you get these unbelievably beautiful sort of very straight Miesian shapes. And the only way to get in budget is to put these big brackets under it, like a parking garage. And we all... we were in a meeting with a precaster, and I thought, oh God, I really don't want to be in this meeting with Stephen where we're describing to him these big brackets. And he fell in love with it. I mean, this was the greatest opportunity in the world. He started to sketch them, and it became the driver of the project for him to have these brackets at all these columns, and he just thought it was the absolute perfect solution. So you also don't know, sometimes the money drives you to the right place. I mean, very often it does, actually. It's a nice way to go.
I think that your first image was really very helpful, and I want to go back to the, not as a father figure, but more of the figure of the poet, or let's say like mountain college and that whole background of shifting regulations rather than following them. Yeah. Where I feel like following them also from last week's lecture, what seems to be the relationship with the structural engineer in general, engineer and architect, is that I feel like the more interesting relationships are when the poet and the orderer, one is like the one who's crazy and the other being like bringing the order, is flipped. Meaning perhaps in some situations you are the poet and the architect is the orderer, or vice versa. That's why I was listening to the Cornell project, because it seemed to me that in a way, I don't know if you felt it was happening particularly for that project, but my question would be for Bert one, where did you think ever that you felt you were more poet than the architect?
Well, I take that very seriously because of my dad. It's very hard for me ever to feel poetic in a family I came from, but...
Not poet.
Yeah. But no, I mean, there are projects where we're pushing it further than the architect is. We feel that it's worth going out on a limb. It's the perfect opportunity, and so we'll present some structure that might be, again, much more driving in a direction that you would typically understand the architect to be in than the architect was prepared to go. Sometimes they buy it, sometimes they don't. There was a house we did where there was an architect prepared to do a more standard floor, and we saw it as a wonderful opportunity just to have the columns support themselves as a bunch of flagpoles, and that was it. And we drove it where they got a very thin roof, where that wasn't actually, believe it or not, part of their initial scheme. What I've learned over the years, and I think some of the success we've had is in also understanding, and I now have a lot of, obviously, you've in this business long enough, a lot of my closest friends are architects, as is my wife. So you sort of get, what I found and what I try to explain to a lot of young engineers, I mean, what's interesting about engineering, especially structural engineering, is that there's a very wide bandwidth. And people look at engineers, rightfully so, as sort of monolithic, that you're designing a structure. But there is, and historically in the field, there's an enormous bandwidth between, and we all do buildings, between, the dreamers and the bureaucrats who review drawings at the building department. And there's everything in between. What I love about our firm, as we've grown and as we've taken on all these projects, is that we really, the people that are successful in our firm, and I am sort of bragging about them, but this, it frustrates a lot of people. It's not easy to use both sides of your brain and inhabit a wide stretch of that bandwidth. And a lot of people don't necessarily succeed at the firm because we ask them to inhabit all parts of the bandwidth, to one day be in a meeting and be on the dreamer side, and the next day come back and make sure they get through all the code issues they have to and get the right set of drawings out so we don't get charged change orders on the job. Having skill in all those ends of the brain is not an easy thing, and it takes practice. And it's also understanding that architects are not monolithic and that some can sell and some can't. And I talk very often to my friends about there are architects, and I don't think I'm talking out of school, there are architects who are successful because they're sculptors. Stephen Hull can sell a project on his watercolors. You get to do things with Stephen Hull that you can't do with a lot of other architects because he shows the client a watercolor, the client buys that idea, and you're off and running. And it's brilliant. There are a lot of architects that are phenomenal practitioners and the details are exquisite and unbelievable. And you have to know going in some sense, I mean, to get back to you have to sort of know going in what path you're likely to take. Now, that doesn't mean you're lockstep the day you walk into a meeting. I remember being in a meeting on a job we did with Richard Rogers where the mechanical engineer just kept saying to him in the beginning, well, of course we need to do this because the ducts will be on the outside of the building, and so on and so forth. And he said, I'm not doing Pompidou Center. This is not, stop. So you don't go in there lockstep, but there is an attitude from the beginning that I think it's important to sort of understand the history of and what you're going down. The thing I always think about, and I talk about, there's a phenomenal book it's one of my favorite books, by James Glick called Genius about Richard Feynman, the physicist. And in the book, and I haven't read it in a long time, so I've paraphrased it over the years. I've probably lost a lot of the emphasis. But there's about a 20-page essay on genius in the middle of the book. And he talks about, in Glick's point of view, and this is just his, but I really always bought into this, that there are people on this earth that are geniuses. And that word's used way too loosely these days. But there are people that are true geniuses that if I stayed up every day for 20 years and studied in a field, I would never be able to see the world the way they see the world. And he puts Richard Feynman in that group. And there are people that are unbelievably brilliant and successful, but you feel like if I had 20 years alone, I could probably understand what they're seeing. They're brilliant, but they're brilliant in a way that may be unconventional, but you could get there. And I think it's the same thing. You have to understand there are certain architects you sit with that you will never see the world the way they see the world, and you want to go along for the ride and just work with them. There are others that are looking for you to come with them and to study what they're doing and to be part of that process. And I think it's really important to understand your place and role, as you go along that journey.
Yeah, I have another question, and I really wish Professor Todd was not here to hear this. But let's suppose for a moment that I'm using you as a consultant, and I've been asked to design Crown Hall. Wouldn't a contemporary optimization of structure in Crown Hall go off the grid?
Yeah. I think I don't know. I'd have to think about that a little bit. I don't know.
I'm thinking of the eccentricities of load, or maybe to some extent what those cores are doing inside, or what's happening down below in the services level of the building, whatever that might be. But I'm sort of wondering whether or not we are now, we would never claim optimization to produce Crown Hall today.
No, I think that's true, and I think that you're absolutely right. And there are projects where there's claims made. There's the other thing I'd say is to build on that, and I'm not really answering that question, but to build on what's to me in the last 20 years or so it's always been this way, but you've been more able to almost get there with the power of the computer and so on. This is an area that I think the computer does help in, and I'm not somebody that believes it helps in everything. That optimization takes on a bigger and bigger meaning. That optimization is not just structural, it's everything. So, and it's a huge matrix. I've been having this battle for the last year, and they're a great group of guys, so I've been having a lot of fun having the battle, but we're designing canopies for this startup company called Solaire, which is doing solar parking canopies, or trying to do them all over the country. And so we've done 3 or 4 of them at this point. And I keep saying to them, because they keep calling me and they say, we want you to do this canopy in Rahway, New Jersey, and it's this wind and this snow, and give us the optimized structure. And so I say, okay, here's the beam, but you could put the columns that hold up the canopy 18 feet apart, you could do it 27, you could do it 40. So they're always yelling at me, just give us the tonnage for 40, 18, 27, optimize it as much as you can. And I come back and I say, it's a pound here and there. And so I was saying to him last week, I said this about 6 months ago, where is the matrix that shows not just my steel, but it shows a hedge fund quant guy who's figuring out that in Rahway, labor costs this, soil is this way, so each footing costs this, the solar panels have to be at this angle, which means that changes the structure, the electricity is at this cost. Where's the local steel fabricator who's going to tell you, I got a bunch of tubes in my shop that are rusting, so I want to use tubes instead of wide flanges? My optimization is almost minimal at this point. Like, I can optimize where it's all the same, and even that, I've often said to architects, well, do you mean optimization in terms of the lightest structure, or optimization in terms of all the same sizes? So you just go out and buy one size and cut it all and put it together? So that even within that, there's a lot of questions about what it truly means. I mean, I think at the baseline structurally optimization, if I was to use it as a pure structural term, it's about load. It's how do you distribute the load so it comes down the same everywhere? But that's might not be somebody else's optimization. I don't know if that.
Well, this is sort of a palate cleanser between your two your appetizer this morning with the students and your entree this afternoon, and we are actually going to feed you a box lunch in between. So to push the food analogy just into the ground, I want to thank you for bringing us a tasty start.